In today's class, let us see about uh, one is the knurling operation, which will be performed on a lathe machine. Okay, right. So we had finished about turning, then taper turning, facing operation. So next operation we will be seeing is about the knurling operation. So what is this knurling? Is that we have seen on certain cylindrical shapes, especially that we want to have a different surface finish in the form of diamond shapes or crisscross shape, where when we hold that particular part, it is easy for us to hold it with a grip, with a firm grip, so that it does not slide away from our hand. Okay, even though it is cylindrical in shape. So one of them, say for example, not exactly on a metallic surfaces. So for our simple understanding, when we see any two-wheeler handle, okay, there is a gripper which is generally made up of a rubber, which will have some particular shape. So that particular shape is given so that we do have a firm grip when we give the accelerator, especially. So even though it is cylindrical in shape, it doesn't slide away, right? Or we don't have a firm grip on that. So because of that, kind of serrations is being given onto the grip. So similarly, we do need it in certain cases on the metallic surfaces also. Whenever it is cylindrical in shape, we can create it by using the knurling operation. So we will see that knurling operation now. Okay, right. So let me play the video. Okay, so here, this is the chuck. This is the chuck, and this is the workpiece, and this is the tail stock, the dead center, where one end of the workpiece is going to be held by the by the chuck. Okay, the other end of the workpiece, okay, can be held by this dead center or the tail stock, okay, which will be positioned over here, so that there is another grip at the other end of the workpiece also. And here is the place where we are going to mount the tool, and this is the tool post that we can see over here in the almost like a square shape. Right? Let us see how to do the knurling operation. So first thing is that we will first mark from where should this knurling start, okay, and where should it end, right? So this is one way of doing it onto the workpiece. So we need knurling from here to here. In this particular place, we want a serrated surface. Okay, so now get the dead center closer to the other end of the workpiece, and fix it over there so that they don't slide furthermore. So there's a firm grip at both ends of the workpiece. Okay. Yes. So now first thing is that we'll have to fix the tool, right? We have to fix the knurling tool in this case. Okay. Yes, this is a knurling tool that we can see over here. It will have at least 2 rollers. So here you can see 1, 2, 3 rollers and 4 on the other side. Okay, right. So now looking at this roller, one of these rollers have serrations markings like at this particular angle. The other one has like this, right? Okay, so we can make use of them the way we need it. We'll see that. What is that? So fix the knurling tool. Fix the knurling tool. So that now what is going to happen is that we have one roller placed over here that is above the workpiece. Okay, there is another roller below this. Okay, below this over here. Okay, so looking at from this end, I'll just draw here. So we have the workpiece over here. The knurling tool roller. One of the roller is over here with serrations, the other roller is over here. So when the workpiece is going to rotate and these rollers are also in contact with the workpiece, the rollers are going to rotate, but these rollers have serrations or markings on them. So these markings are going to be impinged onto this workpiece surface and they get a serrated surface, right? So even here also this roller has also got serrations at a particular angle. So even that is also going to be impinged as they are in contact, right? Okay, we'll see that operation now. They'll fix the tool. Some amount of coolant, especially the oil, is being applied because more amount of heat will be generated. Yeah. So they start the lathe machine. So the chuck starts to rotate, thereby the workpiece is also going to rotate. Okay, and they'll get the tool to the required position where they had marked initially. As of now, the knurling tool is not yet touching the workpiece. Okay, right now they only get the tool in contact with the workpiece. So they moved perpendicular to the axis of the workpiece. Okay, yes, now it is going to touch. Now you can see that the roller is going to start rotating over here because since the workpiece is going to rotate, okay, the roller is also going to is in contact with the workpiece and this roller is free to rotate. So this roller is also going to rotate when it is in contact with the workpiece. So the serrations on this, the markings on this is going to be impinged onto the workpiece, right? And thereby we don't have a smooth cylindrical surface, rather than that we have a serrated surface, right? And now since we need the knurling to be for a particular length, okay, now the tool is gradually moved parallel to the axis of the workpiece. Slowly they are moving it so that this marking is going to be there for that complete length. Okay, so wherever this roller is going to come in contact with the workpiece, yes, there this marking is going to be it's going to be there onto the workpiece also, which we call it actually in technically as serrated workpiece, serrated surface. Yeah. Yes. So here you can clearly see that we have on this roller the markings are like this, and on this roller the markings are in the opposite angle. Say for example, if I make use of these two rollers, okay, and I have the workpiece to be here. Okay, I'm going to make use of these two rollers since both of them are in opposite angle. When these rollers are going to rotate, okay, right? So this is going to make an impression onto the workpiece in this particular angle. I'll just change the color so that you can see it. Right? It is because of this particular roller. Now, when this roller is also going to are in contact with this workpiece, this angle is in the opposite. It's like this. So when this impression is going to fall, it is going to be the opposite direction. So we'll get like diamond cuts. Okay, because both these rollers are in the serrations on these rollers are on the opposite direction. Now, say for example, if both the rollers are of the same direction, then we'll get only, both the rollers have the serration on the same direction, then we'll get only as in one particular angle, right? Yeah. Right. So let us continue with the video. There. Just remove the tool back. Yeah. Stop the machine. Clean it with a brush so that there will be very tiny dust particles present on it. Yes. Now you can see that you can see that here you have a smooth surface, cylindrical surface, but not over here. It's got a serrated surface. Okay, so this is called as knurling operation. So here you can clearly see it's after the operation. Yes, we have much more closer look. Yes, this is a knurling tool. This is one roller which has got serration in this direction. The other roller has got it here and here. So we can make use of the roller. Now, if you look at this, why do we have so many rollers? Is that if you look at this, the markings over here, the serrations over here is too close, but not on this. This is got a little bit far away, right? Similarly, these, right? So it all depends how closely do we need this serrated surface. So here they made use of very fine things. So that is why these diamond cuts are too close, right? So this is a knurling operation. This we get this type of surface only by using a knurling tool, and the operation is called as knurling operation, right? All right. It's a much more closer look. So here you can see kind of diamond shapes or crisscross sections. So this will give a better grip. So this is called a knurl. This kind of thing is obtained only when we do knurling operation. So this is one of the operations. Yeah, right. So this is all about knurling operation. So next we'll see about the threading operation, right? Just a second. Okay. Right. So yes. So the next operation is called as threading operation. So what is this threading operation? Is that we have seen the nuts and bolts on a bolt which is a cylindrical surface. Okay, on that we have a helix groove. Okay, right. So there is a helical groove that is being formed on that. So how do we get this helix? Okay, and if you look at that thread, okay, that helix, that groove that is being formed, it will be uniform throughout its length, right? Now, how do we get that? By using machining operation, we'll see that. Okay, so getting that type of thing is called as the process is called as threading process, or sorry, the threading operation. Okay, right. So this helical groove that has been formed are on the bolts. Okay, it's called as the threads. Okay, right. Right. So we'll see that. Now what you are able to see onto the screen over here is that there's a cylindrical surface fixed to the chuck. So here is the chuck actually, right? Okay, to which the workpiece is being fixed. This is the workpiece, and on which this helix groove is being formed by making use of a cutting tool. So this is the cutting tool that is there, right? This is the sharp edge that is in contact with the workpiece. Okay, so this sharp edge of the cutting tool, okay, should pass only in a particular distance at a particular time or with respect to RPM. Now we would have seen about in physics and all in other in physics probably, where we would have studied something, we would have written it like a wave form, right? Wave form, right? So this, the distance between the highest point of the wave to the other one, yes, okay, we call it as the pitch, right? Or from here, from the lowest point to the next successive lowest point, or from one of the highest point to the next highest point, okay, which the distance is called as pitch. So similarly over here also we have a lowest point, a groove, and a highest point with a sharp tip. Okay, so here also we need to know about the pitch. Okay, what is the pitch. Okay, right? Because every nut and bolt has got a different pitch. Okay, right? So accordingly, we have to form the helix groove that is to be formed at that particular distance. Next thing is that what is the depth of this? What is the depth of this thread that has to be formed, right? So there are certain calculations for this, which is not there for your syllabus, right? Okay, so we'll see only how this operation is being done, okay, and how these threads are being obtained. Okay, yes. So just look at it as the workpiece rotates, the tool is going to move linearly, okay, at the same distance, okay, at a constant distance. Now if the chuck is going to make one rotation, let us assume that the workpiece is also going to move linearly by 1 mm, okay, right? So only then it is going to have the helix form of cut that is going to take place. So this has to be done such a way that for every rotation of the chuck, the tool should move the same linear distance every time. Okay, it should be constant. Otherwise, we will not get a helix shape of uniform pitch. We will not get that. Okay, it will be disturbed, right? Okay. So once the thread cut is over, right, it has to brought back to its initial position. The tool has to be brought back over here, and once again it has to be the operation has to be performed. But for this, once we are getting back the tool over here to the starting position, the cutting should take place once again from the same point in the same groove only, right? It cannot be on somewhere over here. We started initially over at this point, and the next time when we do, it shouldn't start over here. Okay, right? That is not correct. Okay, we'll see that now. Okay, yes, on a lathe machine, okay, animation is over here. On a lathe machine, there will be two rods. One will be the lead screw and one will be the feed rod. Okay, the feed rod is there to guide the entire this carriage. Okay, the lead screw has got a threaded surface. This is a lead screw. Okay, right? This will be locked. Okay, the carriage will be locked to the lead screw only for threading operation, not for other operation, only for threading operation. Okay, so that if the lead screw rotates, okay, the carriage is going to move linearly to a particular distance. Now this lead screw is going to be connected by a set of gears to the chuck that is present over here. So there are gears inside this. So these two will be connected so that if the chuck is going to rotate one rotation, the lead screw is going to also rotate by a required number of rotations. So thereby the carriage is also going to move by a particular distance. Okay, we'll see that now. So during a threading operation, the setting has to be done. First thing is, this is a lead screw, right? There is a split nut. You can see one piece of the nut over here, the other half of the nut over here. These two will be brought close together so that it locks with the lead screw. So this split nut will be locked by using a lever so that now it has been engaged. This lead screw, this split nut is actually positioned in the carriage. So if this is being engaged to the lead screw, okay, now it is nothing but like a rack and pinion system. Okay, if the lead screw rotates, the nut is going to move linearly. Now if you take a nut and bolt, okay, there's a bolt, and now when we rotate the nut over it, the nut is going to rotate, but at the same time the nut is also going to move linearly over the length of the bolt, right? So same thing is going to take place over here also. Once this is being engaged, when the lead screw is going to rotate, this split nut is going to move. But if the split nut is going to move, this is attached to the carriage. So the carriage is also going to move by a particular distance, right? So this is by rotating the lead screw. Okay, right. So if we just look here, if the chuck rotates, the lead screw is going to rotate. The carriage is also going to move by a linear distance. So the stool will also move by a particular distance with respect to the rotation of the chuck. Okay, so thereby the spindle speed is required. Okay, lead screw speed is required, and based on these two, the pitch is also going to, we are going to get. Okay, so if the speed of the spindle speed is n, the lead screw speed is twice, okay, 2 times 2 rotations, then the pitch will be twice, it will be far away, because for 1 rotation it is going to move twice, so that means it is going to move twice the distance, right? Okay, so like this, based on this only we get different pitch. Okay, right, so this is the set of gas, so this is the chuck. So here we have the chuck, to that shaft there's the main gear. Okay, this gear is connected to another series of gears over here. Okay, and there is one gear attached to this lead screw shaft over here. So based on these interconnections, the pitch is going to be determined. Okay, so we have to set these gears to the required pitch that we need. Okay. So we had studied in gear trains about simple gear trains and compound gear trains. Yes, this is the gear from the chuck. Okay, so if we engage them, yes, the lead screw is also going to rotate. So here is the gear for the chuck. Okay, mounted on the shaft of the chuck. Okay, so these gears are meant for adjusting it, and ultimately this red color gear that is being indicated over here is connected to the lead screw. So based on this number of rotations that we get, we will be able to vary the pitch. So in this case, there are 1, 2, 3 into 9 gas mounted over here. So thereby we'll be able to get 27 different pitches that we need. So on every lathe machine, there will be a chart for this. So this is the lever. This is the lever to set the pitch. So if we place it over here with all the other settings, so what is the pitch that we'll be able to obtain will be mentioned on this chart. Okay, so yes, so just look over here. The workpiece is going to, the tool is going to come in contact with the workpiece at one end of the workpiece from starting from outside, and when it is going to rotate, the chuck is also going to rotate. The lead screw is going to rotate. The tool is going to move linearly, right? So first time, see, just look at that. It has to, the tool should always be in contact with the same group, right? Okay. So when we are going to give the next pass, okay, we have to rotate the chuck in the opposite direction and get it back to its original position and perform repeat this operation once again. Okay, just a second. Yes, so we'll see the actual threading operation now. Yes, these are the set of gas mounted onto the which is present in the headstock. That is just before the chuck. Okay, we have to adjust these gas. Okay, so now here we have a cylindrical workpiece. Okay, with a threading tool. Okay, the threading tool, now it is, as of now it is outside. We have set the gas. Okay, right. So now look at it. The lead screw is engaged. Give a particular depth of cut first. Okay, and then engage the lead screw. Start the machine so that the chuck starts rotating, and just leave it. Okay, so yes, so you can see that the one pass is over. Okay, now we have to do the second pass so that required depth of cut is also there. Okay, so that we get a V shape on the thread. Okay, so that we have to get this tool back once again to its starting position, and the cutting tool has to pass into the same groove. So we'll see that. So now they'll rotate the chuck in the opposite direction so that the tool moves back automatically to its starting position without touching the workpiece. Now give some more depth of cut and start the machine. Now you can see that, now just look at this, the cutting tool is going to pass in the same place, in the groove, in the same place once again, okay, with little more depth of cut, thereby removing the material. Okay, yes, so like this several times this operation has to be done so that a complete thread is going to be formed. Now we can see it is not in V shape. The grooves are formed, but the threads are not in V shape. Yes, so again and again, the tool is going to be in the same groove only. Okay, it is not going to be away from the groove that has been formed, right? So they are coming back to give the next pass. Right, more amount of heat will be produced. Okay, and during this operation, that is especially for knurling as well as this threading operation, the speed of rotation of the chuck will be less when compared to turning operations, right? So now you can see after several passes, now we can see a V thread that has been formed. Okay. Yes, now you can see that sharp V threads are being formed. This is a rough finish. After this, a finishing thread operation has to be conducted so that all these small burrs are being removed and we get a smooth surface. Okay, I mean a smooth finish. Right. So this is about threading operations.